Welcome to another free video for thinkingParticles subscription drop 9. In this video we will discuss how to create a water fountain effect, especially how to create the fluid simulation in thinkingParticles. This is another video brought to you by Cebus Visual Technology. Before we start with the video, let's have a look at the scene setup. Keep in mind that this video is a live recording, so everything you see here is done on one machine. The recording of the video, voice recording, and the simulation. Let's have a look at the scene. We have multiple boxes here in the scene with Boolean operations, so nothing really special or complicated. So even a starter in 3D Studio Max can reproduce this scene. As I already mentioned, the object is not really complex. The only other thing I've built here is the two cylinders or poles that create kind of the illusion that this is a physically plausible object, but that's practically all. Just a few boxes, two cylinders and a floor, and nothing else. The dummy object we can see up there has a purpose. The dummy is meant to act as our fountain or particle emitter. So let's start with creating the particle system. We go to Particle Systems and create our thinkingParticles helper. You can place that anywhere in the scene, it doesn't matter. It's just a container for our parameters and procedural setup. So you click the properties and we come up with the thinkingParticles user interface. I scaled that user interface down for now because everything is on one screen. So the first thing we are going to do is create some particle groups. For sure I will need an emitter particle group, and we need a particle group that will hold our water particles or fluid simulation particles. So I'll name that water. The next thing I'm going to do is I'm going to create dynamic sets. So we need to just scale up the user interface a little bit, and I'll create 3 dynamic sets. First dynamic set is meant all the nodes and operators to create particles. So everything that has to do with creation, I'll put in the create dynamic sets. Then we need a gravity, I'm pretty sure, gravity force, and the last one, the most important one, is the simulation dynamic set. Let me just move that there so that we have maximum view of our workspace. So now let's start. We want to create the particles, and as I mentioned, this dummy object here is placed right underneath the pole. So I want to kind of simulate or make it plausible that there the water comes out here, sprinkles around and collects in the container, in the first box, and then overflows into the other box, and so on. So let's get the dummy object into thinkingParticles as an emitter particle. So we are going to use the ObjToParticle node, and the ObjToParticle node just allows you to pick any 3D Studio Max mesh or object and get it into thinkingParticles. And this is what we've done. Now we have to decide where should this particle be created. So we want to create it in the emitter particle group. And for sure we check the ObjToParticle option, because if we move around the emitter, we will also move around the emitter particle. So that gives kind of a one-to-one connection to our particle emitter. And we can see when I reset the simulation, there's one particle created right at the pivot point of the dummy object. So from that point, we want to emit now particles. So how do we do that? We create a flow emitter because we want to have a constant flow of fluid or water in our case. So the flow emitter needs as an input our emitter particle. So from this particle, the flow emitter will emit our water particles. I could connect the born particle from our ObjToParticle right into the flow emitter, but that would not work really because it's just at birth. So you would have one event, but we want for every frame, every subframe, we want new particles created. So I'm going to choose the emitter group feed that into our flow emitter, and that's the setup how we need to do it. So if I play this back, we should see some particles created. But before we do so, we need to make sure where do we create the new particles, our fluid particles. They need to go in the water group. And the rest, see, looks pretty good. Let's just keep it in the default values. Maybe increase the size a little bit of our emitter to make it more according to the pipe down below. And that's about it. Let's just try out how it looks like. So I'll restart the simulation and we can see something is happening. It creates some particles. You can see that. Let me just zoom in, and yes, it creates particles, but it's not like a water fountain. So I want them to spray out up high and then fall down. So we need to give them some speed, a little bit of speed. So I'll start with 50 and let's see how that goes. And now we have a particle emitter. There's our water fountain. However, look where the fountain shoots. It shoots into the solar system. So we need to make sure that our particles return from space, and they return fast from space. So we have to add some gravity force. The great thing in Thinking Particles is we fully work procedural, so that means we can decide which particles should be affected by gravity. I'll pick the water particle group, and then I'll bring in with my tab key and search a force. I just type in force and choose our force node. I'll connect the particle, and there we go. So our particles, and only our water particles, will receive the force, not the emitter. And let's have a look how that force looks like. And so far I can't see anything. Let's zoom out a little bit. And yes, we can see it slows down, turns around. That's a high pressure water fountain, I would say. This is meant to be on a desk or on a table inside, so we don't want this high pressure fountain. So what we need to do is just increase the gravity, because we are not in space here. So that kind of looks good. I think that's fine with the force we have here. Particles are pumped out, shoot up and return. So that's pretty good. However, particles are falling way through down into the planet's core. And this is another thing we don't want. We want a collision with our box. So now we go into our simulation. And here I see I did a mistake. I created my create nodes in the simulation dynamic set. I'm lazy, I'm just renaming them. Nothing happened. Let's just pretend nothing happened. I'll move the sim down. You can drag and drop down. And the create up. So now we have the correct order. We create the particles. Particles are getting affected by gravity. And now we're into the fun of creating our simulation nodes. The first thing we want to create is our flow simulation nodes. So everything that's to do with fluid simulation is our flow nodes. So I'll type in flow, and the first thing we create is our flow group. Then we will create our boundary. And there is a reason why I'm taking care about the order I create these nodes, because the order is very important. And I will create as well our flow solver. As I already mentioned, the order of these nodes is important. The first one should always be the flow group, and the last one should always be the flow solver. So make sure when you are setting up fluid systems that your flow group is the first and the flow solver is the last in the hierarchy. Now let's just pick the correct values. So we want the flow solver to affect our water particles, and our boundary should work with the flow solver, and here we have the flow solver. So that's our basic setup, and we can already try to see what's going on if we would just play back or restart the simulation. And we can already see we have some discoloring or different coloring here happening. And we can see particles are there, but still we have no collision. So in the boundary, we need to pick our boundaries. So we pick the first box and we make sure then we turn on unyielding. We don't want the boundary to move on collisions of particles. And that should give us the effect we're after, hopefully, if everything goes right. Yeah, and here we go. Particles are no longer falling down into the planet's core. However, we can see that particles are falling through the other boxes or the other containers we've built. So we need to add these containers as well as boundary conditions. But before we do so, let's have a look in the create section, because we need more particles created. So I'll change the amount to 1500, and also the speed I want to increase a little bit to get more height when the particle or the fluid shoots out. So, and there we see nice amount of particles. And as I mentioned before, still it's dropping through all the other containers. So we need to make sure we add the other containers as well in our collision. Let me just turn this to dots. I just like them better than the plain ticks. And there we go. So that looks pretty nice. Is fast to simulate, and let's adjust a little bit more the boundary thing. So bring in the other objects. So let me bring in this layer, the other layer, and this layer, and the lower layer. And I want also, just to be precise, the cylinders, because water could flow around in the lower pool, and also the support box down there. So now everything is in the collision group or flow boundary group, and it should work now, hopefully. Let's have a look. Yes, it fills the upper container, then it overflows, the second container overflows, and so on. So we have a nice flow from up to down. So far this looks pretty good when we use the top view. We have a fluid-like behavior, so all looks fine. However, I want more detail and a little bit more volume in our fluid simulation. To get more detail, I'll reduce the smoothing radius. I'll put it to 3. And let's just have a look how it looks like when we go with a smaller radius and we get more details. I can see that particles are now closer together. But we need to counteract a little bit now our smaller radius with a higher density or lower density value. So that increases the pressure a little bit. We can see that in the colors. However, the volume is totally lacking. We don't get any volume in our fluid. So I'm increasing the decompress, and the decompress is the force that fights against the gravity. And now you can see our water level is rising. However, it looks crazy like popcorn. I don't want popcorn, I want fluid. So the water level should rise smoothly without this cooking or popcorn-like effect. So to counteract that, we are just going to increase the subsamples of the solver. It's better now. It's much smoother on the surface, but still the surface has a high oscillation. So there's a lot of bouncing back and forth. So I'll increase the subsample one more step just to even out the pressure calculations. And now it starts looking really nice. It's still lifelike, it's not too viscous, it still behaves like a fluid, like water. And we get really rising water levels, so the volume is okay. The only other thing I want to adjust is a little bit of friction, just a tiny bit of friction, because the particles should not behave like they were on ice. So now the water will just accumulate in the container until the pressure itself pushes it out. So that looks more realistic. So first we fill the container and then the water flows over into the next container and so on. So that's about it. Smoothing radius, density, decompress, and friction. So just 4 simple parameters. There's one other parameter we did not touch yet and I really don't like, is the particles behave not really like the small scale fluid. It's just not showing the surface tension. So I'll increase the surface tension. I'll put this pretty high because it's a smaller scale. So I want to see the droplet building and puddle building. And we can see now this nice tongue, this tip that is created through the water tension, which looks like much better. It's hard to see. I'll think I'll change the display mode in a second, but yeah, we can see it's nice surface tension. Let me just go to performance. Now we see it. So we get these water drops, these puddles, nice surface tension. That's what I want to see in a fluid simulation. So we're getting there. It's really nice coming along. The only other thing I might not like is the nature of simulation. So we fill these containers, and to get a nice animation cycle or sequence, I would have to wait or simulate through all frames until every layer or every level of my water fountain is filled with particles. So that can take quite some time, and we could help a little bit with initial state. So we could do a simulation of 400 frames and take that, cache that out, and use that as our starting frame. But that's the nature of simulation, right? If you want to have a physically accurate simulation, you really need to simulate Mother Nature. So we could also try increasing the amount of particles. So we pump out more particles in less time. So that will also create more particles and more fluid in a shorter amount of time. However, we face the risk of overflowing our first container. If we pump in more volume that is flowing off, we have no gain at all in our simulation. So we need to keep the flow steady. So the only thing is to just simulate through a certain amount of frames and start from there. Or we use another great feature we have in thinkingParticles. We could pre-fill all the levels of our simulation. We could pre-fill the containers with fluid already. Very simple, very easy and fast. So what do I mean with that? I mean that if we use another particle generator and throw the particles into the water particle group, we would be able to just born some particles in these individual levels of the water fountain here. Let me just move the particles around, control click, and I can move around my nodes. And the node I'm looking for is the water level. With the water level node, let me just increase the workspace a little bit more. The water level node allows me to use a water level object that decides the height of my water level, and a ground object that is, so to say, my ground or boundary object. So between water level and ground object, particles will be created. To do so, I'm going to show you how this works. We already have some planes, but I will show you how in principle this system works. We create a simple plane, nothing fancy, nothing special. And the plane should just cover our container. So I'm just dragging around the plane, and we need to be kind of careful how big our plane is, because we don't want the plane to intersect with the border walls, because then we would create particles inside of an object. So I'll just move them a little bit around and make sure that we are not penetrating or intersecting our walls here. And because we're 3D, we have to make sure it's not happening in any dimension. So the plane looks good to me, and the plane actually defines the height of the water level. So from this plane, we will start creating particles downwards. It's along the object z-axis. So I'll add the plane object, and I will need to add the ground object. So the ground object is my box or my container. And we have the visualization, the show is on, the show option, and that shows us the particles that are created. So right now a grid size of 10 is way too high. I'll set it to 1, and that's a high density. I don't need so many, so let it set to 1.4. That looks good. Now when I go into, let me just turn off the show, and I'll switch the mode from test to generate. It will generate the particles. So I'll reset the simulation, and there we go. Here are our particles. Now you can see they have the wrong color, they have no pressure, because we need to define where these particles are created, in which particle group. And that's done down here. So we decide all these particles go into the water group. I'll reset the simulation, and there we go. We already have a nice water pressure there, and we can see right from the start the container is filled up to the water level, and it's flowing out nicely. That's what we want. So we control that with a simple plane that we place inside the container, and it will create all the particles for us. And we pre-fill the container, and from frame 0 it will start pouring out the water. The only thing left to do is just hide the plane, but in this scene I already prepared the planes, so I'm going to just delete this plane again and use my already prepared plane. So I'll delete that, and we're now going, let me just bring that back, add all our water level objects, plane 0, plane 2. So that's all the levels. So I already placed the planes in the right height and position. So that's it. And then the next thing we're going to do is add also all the other containers, or this thing won't work. So I'll add this container, add this container, this, and this container. So we've added all the containers now. So, and we can be sure that everything is made at the level filled with particles. The last container I didn't put a plane there, so this is why I removed it. So if you want, you can create the last plane as well. So now we have a strange effect here. I can already see that in my side view. Let's just play back and look what's happening. So we have now something weird happening. Water is splashing out like an ocean wave. So why is that happening? That's happening because we didn't check the first level stop option. So if we have overlapping planes, they can create underneath or restart from fresh underneath, creating particles. So what we need to do is we need to check this first level stop option. Let me just reset the simulation, and you will see instantly now everything is clean and smooth surface. So all we have to do is check the first level stop option, and if we don't do that, we get this weird behavior where we have double the particles in some overlapping areas. So just make sure first level stop in these kind of when you have overlapping water level objects. Let's play this back again, and now everything is smooth and nice. So particles are created and are flowing now from level to level out of the containers. The next thing we want to explore maybe is get some kind of surface, because I want to actually see our fluid. So we do that by creating just another dynamic set where we just name it surface. And I'm doing the same thing, click inside the dynamic set, press the tab key and type in open. And we are using the OpenVDBShape. That is creating out of the water particles. We choose the particle group. We want to create a surface, and we want to adjust maybe some parameters, or maybe not. Let's have a look how it looks like when we go with the default. So we have the particles overlapping, and also in the viewport we have the wireframe on. So let's turn off the wireframe. So we can see we have this weird pattern. So our surface is not really smooth. We can see these little cracks there. It becomes smooth as more and more the particles will mix, but that looks good. So let's do one more adjustment. We want to have not these broken up or rough surfaces. So we are going to have a smoothing over the surface. We do that with the Gaussian smoothing. And then we are going to see how that looks like. So we have now a much smoother surface, but now we have gaps in our surface. So particles seem not to be connecting. And let me just turn on the particles, and we see there's a lot of particles without surface. So we don't want that. So how can we counteract that? We can increase our radius of our surface. So now we look for more particles, and we get now a smooth surface, and it looks like water flow. However, it's very inaccurate, so I need to reduce the radius scale, but now still particles are missing and not considered in the creation of the surface. So I increase the resolution, and increasing the resolution will allow us to catch more particles and create a much nicer flow. And by increasing the resolution, I can go lower with the radius, and this is how you, with trial and error, get your perfect smooth surface. And we can now even see the circular waves on our surface with that. So that gives us a really nice surface and nice look of our fluid. This concludes our video. I hope you enjoyed recreating this video on your own. And if not, I hope you enjoyed watching it. And keep in mind, all the video we have seen here was done on one machine, recording and simulation all live in real time. So what you see here is always real-time simulation going on. Thanks for watching. Check out our other videos as well. See you. Goodbye.